All right, we're back. We're on page 3 of notes 12 of Calc C, and we're talking about arc length. And these problems say to find the exact length. And that must mean that something kind of magical happens because it looks like it would be challenging to do that. So let's see what we can do. So first of all, this one doesn't give us an interval, which means there must be some like inherent domain on which to look. And so there's two things causing domain issues, I guess. The first one is that arc sine is only between -1 and 1, but there's a radical. So like based on just this part, I would say that the domain at most is 0 to 1. Right, because you can do the inverse sign of 1, you can do the inverse sign of -1, but you can't take a radical of a negative. So 0 to 1 is from there. And then this other part like is also from 0 to 1, like between 0 and like 0.5 minus 1/4. Yeah, so I think it's 0 to 1. All right, so now I gotta find dy dx. And then something better happen because this is not looking great. So dy dx is gonna be 1 minus 2x over 2 square root of 1, no, of x minus x squared. So chain rule. And then this, okay. The derivative of arc sine is 1 over the square root of 1 minus u squared times the derivative of u. So this is going to be 1 over 2 root x root 1 minus x. Okay, so I'm going to do a weird thing here where I'm going to take this and distribute it in to the radical. So I'm trying to get a common denominator, and they actually have a common denominator. It just doesn't look it. Minus 2x over 2 root x minus x squared plus 1 over 2 root x minus x squared, right? Because if I bring radical, I'm not even bringing it in. I'm just like, it's radical a times radical b is radical ab. So you just like multiply them together. All right, so now I get 2 minus 2x. Well, I could have simplified out that 2 root x minus x squared. So 1 minus x over root x minus x squared. Which actually, if you factor back out the radical x, you can make, it doesn't really matter because we're just going to do the next step anyway. So that's dy dx. Good grief. Okay, so then we got to do something with that. So I'm going to highlight something here. This is dy dx. All right, so we're going the integral from 0 to 1, 0 to 1 of the square root of 1 plus this dy dx squared. So 1 minus x over x squared dx. Okay, so that's the integral from 0 to 1 of what? All right, so when I square it, I'm going to get, I'm going to do another step. 1 plus 1 minus x squared over x minus x squared, which is x times the quantity 1 minus x. So actually, I'm going to factor that right now and say it's x, the quantity 1 minus x. And you see, like, some stuff is happening here, I think. So this is going to be the integral from 0 to 1 of the square root of, I don't know, is like magic going to happen? Maybe 1 minus x, because you can cancel over x dx equals 0 to 1. I'm sure there's like a place I could have simplified this really quickly, but I did not see it. X, what am I dealing with here? I have x plus 1 minus x over x. 1 over x. Really? So that's x to the -1/2. Integral 0 to 1 of x to the -1/2. Right, it's x to the negative first, but then 1/2. So that plus 1 times reciprocal 2 root x from 0 to 1. Ah, really? 2? Should we check that thing on a calculator? Probably. Let's do it. Let's see. And then I'll do I'm gonna try to do the next one. Let's just do the arc length thing. Arc length, square root of x minus x squared plus arc sine of square root of x. X goes from 0 to 1. 2. Okay, so that was a surprising result, but it worked out. That's what I'm saying. Like, either the problems are like incredibly written so as to work, or they'll be calculated. Like, there's kind of like no in between, because you can't just take a random function and be like, find the arc length and like think it's gonna work. It's gonna work by hand at least. So let's see how amazing this one is. X over 2, 1 over 2x. I think before you square that, it's a much better idea to like simplify. So this is x squared minus 1 over 2x. So we're going to do the integral from 1 to 2 of the square root of 1 plus this thing squared, x squared minus 1 over 2x squared dx. Algebra 1 to 2 square root of. All right, I'm gonna get a common denominator at the same time. So the denominator is really 4x squared. So I get 4x squared plus square x to the 4th, multiply them together times 2 minus 2x squared and square the last. Whoop. And then over 4x squared dx. So this simplifies. I mean, it must simplify into 4th power. It's fun. X to the 4th plus 2x. Ooh. Okay. Ooh, we got some perfect squares. This is gonna work. You can tell. 1 to 2. Square root of. So you get the quantity x squared plus 1 squared over the quantity 2x squared. We do our square root thing. They're both positive on that interval, so it's going to be, you don't need the absolute value. You basically never need the absolute value with these because, I mean, I don't want to say like because, but they're just too hard if you do. Like, I'm sure that in a textbook, like there's, like, you know, the A problems, B problems, C problems, and challenge problems or whatever. I'm sure the challenge problems have like loads of those. 1 to 2, x over 2 plus 1/2 1 over x. All right, we can integrate that. So this is 1/4 x to the 4th. Is that the same thing we started with? No. Oh, whoa, holy crow. It is, and I'm wrong. Okay, so it's actually 1/4 x squared, which is the thing we started with. That's weird. Plus 1/2 the natural log, the absolute value of x. Is that the thing we started with? That's definitely not the thing we started with. We're going from not 0, 1 to 2. What do we start with? The arc length formula is like, oh wait, what? Oh my God. It's like almost exactly the thing, but like a plus instead of a minus. Is that right? We'll find out. All right, plug in 2, you get 4 over 4 is 1 plus 1/2 the natural log of 2. Minus, plug in 1, you get 1/4 plus 1/2 the natural log of 1, but the natural log of 1 is 0. So you really just get 1 minus 1/4 is 3/4. This is going to be gross. And then 1/2. Give me 1/2 the natural log of 2, which, like, there's a million ways you could write. Okay, let's check this one on the calculator. This one's weird. Also, I've never noticed how similar, well, unless I made a mistake. I've never noticed how similar the arc length formula type deal is to the original. So I got to type in the original function. And I get 2 plus 2. 2 of them. Why? Oh, yeah. Okay. That's exactly the answer that we got. They just got a common denominator. We got 3/4 plus 1/2 natural log of 2. And then you get a common denominator. The common denom. There you go. You can see they are the same. Woo! All right. So they're either going to be clever, in which case you know it's going to work. You just have to keep like playing around with it until you get something that like pops out. or they're going to be set up but do not evaluate. I'm going to come back in the next video and do the next problem, even though it's like probably kind of short, but I feel like this video is probably kind of long. So yeah, I'll be back and I will see you there.